Hello students, welcome to class 12 physics. In this video we are going to solve another illustration of chapter number 2, that is electrostatic potential and capacitance. So now let us see the illustration number 2.9. A network of 4 10 microfarad capacitors is connected to a 500 volt supply as shown in figure. So you can see over here we are having a network of capacitor, right? Here we are having 4 capacitors and it is connected to the potential difference, that is the supply 500 volt. Now first what we need to find? Determine the equivalent capacitance of the network. That means here we are having 4 capacitors. First we need to see in what ways these 4 capacitors are connected. We have already studied about the series connection and the parallel connection of the capacitors. So first we need to resolve this network and then find the equivalent capacitance. Also, we need to find the charge on each capacitor. So first of all, let us resolve this circuit. Right? What we are having here, let us start from this point A. Right? From point A, right, we are having one capacitor like this. Over here plus Q charge near point A. So plus Q, here it is minus Q. Then this plate of the capacitor is connected to point D, right? Then from this point D, it is connected to the positive plate of the capacitor of C2. So let us say here we are having, here there is a C1, here we are having C2 in such a way that here plus Q charge is connected to this terminal. Here we are having minus Q charge, that is the negative plate of the capacitor. From this negative plate of the capacitor, which end is there? Here point C is there. So here that is point C. That point C is connected to the positive plate of capacitor C3. So here we are having C3. Here we are having plus Q charge. Here again we are having the negative charge. Now here we are having point D, right? Now see, this A is connected where? It is connected to the negative plate of C4. So A is connected to negative plate of C4 and the positive plate with plus Q charge, it is connected to point D. So let this positive plate of capacitor connected to D. Right? Now you can see this point A, right? What is that? The point A which connects this negative plate of C4, right? Here it is connected to the supply, right? So here we can say it is given the supply 500 volts. Over here, the other terminal of the supply, it is connected to D point as well as to the positive plate of C4. So to the D point as well as the positive plate of the C4, that is connected to the supply. Right? So from this you can see that these 500 volt, right? This supply is given to this C4 component as well as it is given to this AD point, right? So here between A and D, these 3 capacitors are told to be in series connection, right? Because we know for parallel connection the potential difference is same, right? So here the 500 volt is given to the C4, that is capacitor C4 at its 2 terminals, as well as the same 500 volt it is given to the point A and D, and between these A are the 3 capacitors. So we can say these 3 capacitors, right, they are in series connection and that 3 capacitors are in parallel with this C4. So first of all what we need to do? We need to get the equivalent capacitance of these 3 series capacitors. Here C1, C2, C3 are in series, right? So equivalent capacitance let us term it as C dash, right? For equivalent capacitance for series connection, the formula is 1 upon C dash equals to 1 upon C1 plus 1 upon C2 plus 1 upon C2. That is 1 upon C dash. Here what is that? In the data it is given that all the 4 capacitors is having the value as 10 microfarad, right? So here let me write C1 equals to C2 equals to C3 equals to C4 equals to 10 microfarad, right? So here 1 upon 10 plus 1 upon 10 plus 1 upon 10 which is equals to 3 upon 10, right? 1 upon C dash is equals to 3 by 10. So what will be C dash? C dash will be 10 by 3 microfarad. So this is the equivalent capacitance for 3 series connected capacitors, that is C1, C2 and C3. Now see, instead of these 3 capacitors, right? Now what we are going to do? Here we are having term A. Instead of these 3 capacitors, we are connecting an equivalent capacitance C dash, right? And that is in parallel connection with C4, right? Okay. Now this is to be said in parallel connection. So now we need to find the equivalent capacitance of these 2 parallelly connected capacitors. Now C dash and C4 are in parallel connection, right? So the equivalent capacitance. So equivalent capacitance, for that let us term it as C, right? For parallel connection, what we need to do? We just simply add up this capacitance values. So let us denote equivalent capacitance by C. So C equals to C dash plus C4, right? C dash, that is what? 10 by 3 microfarad plus C4. C4, that is what? 10 microfarad, right? So here when we take the LCM, what we get? 30 plus 10, that is 40 by 3 microfarad, right? Or when we solve this, we get C equals to 13.3 microfarad. So we got the first determine the equivalent capacitance of the network. So we have solved the first part, the equivalent capacitance for all these 4 capacitors in network, that is equals to 13.3 microfarad. Now what we need to find? We need to find the charge on each capacitor, right? So here in this network you can see these 3 capacitors are connected in series, and we know when the components are connected in series, right, then charge is same for all the components. Potential difference is different for all the 3 components. When we talk about the parallel connection, for parallel connection what is the point? Charge will be different but potential difference is same, right? So first of all let us find the charge on these 3 capacitors. Here charge is same but potential difference is different. For the series connection of C1, C2, C3, charge is same, right? So and potential difference is different. Now see, these 500 volt, this potential difference is given between A and D, right? So when I write V equals to, here the potential difference at each component, that will be different. So the total V is equals to V1 plus V2 plus V3, right? Now let us write that in terms of capacitance. So that is equals to V1 is what? That is Q by C1, right? Here because all these three components is having the same charge, we will be just writing Q instead of Q1, Q2 and Q3. So Q upon C1, V2 is what? That is Q upon C2, and V3 is what? That is Q upon C3. Taking Q common, that will be 1 upon C1 plus 1 upon C2 plus 1 upon C3, right? Here 1 upon C1 plus 1 upon C2 plus 1 upon C3, that is what? That is 3 by 10, right? So 3 by 10 over here. Now we need to find this Q. Take Q as the subject. Take this 3 by 10 over this side. So it can be written as 10 by 3 into V, which is 10 by 3 into 500. Right? Here it is microfarad. So let us write it as 10 raised to minus 6. Right? So when we calculate this, the value we get is 1.7 into 10 raised to minus 3 coulomb. Thus, the charge on each of the capacitors C1, C2 and C3 is 1.7 into 10 raised to minus 3 coulomb. That is charge on C1, C2 and C3. Now we need to find the charge on this capacitor, right? Charge on capacitor C4, right? Again, what equation we will be using? We will be using the equation C equals to Q by V, right? So here we are finding for capacitor C4, right? Charge on that will be Q dash upon V, the potential difference applied to this capacitor C4, that is 500 volt. So we can simply write it as V. Thus Q dash equals to C4 into V, which is equals to C4 is what? 10 microfarad, that is 10 into 10 raised to minus 6, and V, that is 500 volt, right? So what we get the value as Q dash equals to 5 into, that is 5.0 into 10 raised to minus 3 coulomb. So this is the charge on the capacitor C4. So students, you may note down this numerical. Now let us see another illustration. 2.10. A 900 picofarad capacitor is charged by 100 volt battery. How much electrostatic energy is stored by the capacitor? Right? So as you can see in this figure A, we are having the capacitor C and capacitance is 900 picofarad. That is 900 into 10 raised to minus 12 farad. volt. What we are asked to find? The electrostatic energy that is stored by this capacitor. That means you need to find the U, right? The potential energy, electrostatic energy. Now see here in this data what we have C, we have V, we need to find U, right? So for this we are having three equations as already we have studied in the theory part. One is U equals to half CV square, also half QV, also it is equals to half Q square by C, right? We are having these three equations. Now see, as per the given data we are having C, we are having V, we need to find U. So we will be using these equation first. Thus, electrostatic energy stored in the capacitor, that is U equals to half CV square, right? Here half into capacitance value is 900 into 10 raised to minus 12 into V square, that is 100 raised to 4, right? When we solve this, what we get? We get 4.5. Here it is square, so 10 raised to 4, thus to 6 and 10 raised to minus 6. So our answer is 4.5 into 10 raised to minus 6 joule. So electrostatic energy stored in the capacitor is 4.5 into 10 raised to minus 6 joule. Now let us see the second part, that is part A. The capacitor is disconnected from the battery and connected to another 900 picofarad capacitor. That means now we are removing this capacitor from this supply, right? And instead of that, we are connecting this capacitor to another capacitor which is having the same capacitance value, that is 900 picofarad. That means here the capacitance value of both is 900 picofarad, right? But now because it is disconnected to battery and it is connected to the chargeless capacitor, the charges get distributed to another capacitor. So initially what we are having? For this capacitor we are having plus Q charge and minus Q charge. So when we connect another capacitor, the charges get distributed to the another capacitor. So half of the charges is given to this capacitor, this plate of the capacitor. So here the positive plate will be having charge plus Q by 2, and for the another capacitor also the positive plate will be having plus Q by 2 charges. In the same way, the minus Q charge also get distributed to this plate of the capacitor. So for both the negative plates, the charges will be minus Q by 2. This is how charges get distributed. Now for this system of capacitors, what we need to find? See, what is the electrostatic energy stored by the system? That means for this system of capacitors, we need to find the electrostatic energy. Now see, what we are having? Now because we are connecting another capacitor, charges get distributed. So now the charge is, new charge is Q dash is equals to Q by 2, right? So here we are having Q dash, the new charge, right? As well as what we have given, it is connected to the capacitance, into 10 raised to minus 12 current, right? Again we need to find U. So here what we are having? Q dash, here we are having C, and we need to find U. So which equation we will be finding over here? We will be using these equations. U equals to the electrostatic energy. Equation is U equals to, using this equation, half Q square by C. Right? But here, first of all, here we are having Q dash, so let us write it as Q dash square by C. Right? Here, what is Q dash that we need to find? Also, Q dash is equals to Q by 2. Right? And what is Q? How can we find that? We can use the equation over here. Right? That is C equals to Q by V. Right? And C equals to Q by V. Therefore, Q equals to CV. Right? For this first part, Q was what? Here we were having C, we were having V. We can also find Q from this. Right? For the first figure. So Q is equals to CV. Capacitance for this part, it is 900 into 10 raised to minus 12 into, what is the potential difference? Here the supply given is 100 volt. Right? So Q over here, that is equals to what? 9 into 10 raised to minus 8 coulombs. Right? Here we are having Q. We got the Q. So what will be Q dash? Therefore Q dash equals to Q by 2. Right? So Q is what? 9 into 10 raised to minus 8 divided by 2, that is 4.5 into 10 raised to minus 8 coulomb. Therefore Q dash is equals to 4.5 into 10 raised to minus 8 coulomb. Now we can use this equation in this formula. Thus, U equals to half Q dash square by C. That is half. What is Q dash square? That is 4.5 into 10 raised to minus 8 square. And capacitance value. That means for these capacitor which is connected to this capacitor, its value is 900 picofarad. That is 900 into 10 raised to minus 12. So when we calculate this, we get the value as 2.25 into 10 raised to minus 6 joule. So the electrostatic